Imagine Earth's immense 4.5 billion year history compressed into a single year, a cosmic calendar of sorts. It's a mind-boggling scale, almost impossible to truly grasp. Dinosaurs, those magnificent creatures that once roamed the Earth, appear in mid-December, a relatively recent event in this grand timeline. And modern humans, the species that currently dominates the planet, arrive just minutes before midnight on New Year's Eve, a fleeting moment in geological time. Our entire recorded history, every empire that has risen and fallen, every groundbreaking invention, every war and peace, lasts only seconds in this cosmic calendar, a mere blink of an eye. Most of Earth's story is a mystery, a vast and largely unwritten narrative pieced together painstakingly from fragmented fossils and ancient rocks. Each discovery is a clue, slowly revealing the secrets of the past. But what if we've missed entire chapters? What if crucial pieces of the puzzle are missing, leading us to incomplete conclusions? We naturally assume we're the first technological species to emerge on this planet. But is that just because we haven't yet found definitive evidence to the contrary? Could there have been others before us, civilizations lost to time? Science at its best asks uncomfortable questions, the kind that challenge our assumptions, challenging our perceived place in the vastness of the universe. What if, long before us, another species rose to prominence, built sprawling cities, and then vanished without a trace, leaving behind no easily detectable remnants? This isn't about fantastical ancient aliens visiting Earth. It's about the intriguing possibility of a homegrown terrestrial intelligence that predates our own. Earth is not a static museum frozen in time. It's a restless, dynamic, and ever-changing planet, constantly reshaping itself. Its crust relentlessly shifts and grinds. Mountains rise majestically only to erode back into the earth, and oceans expand and contract, come and go, constantly recycling the surface and slowly burying the past beneath layers of sediment. In the face of such immense geological forces, would any tangible evidence of a past civilization be able to survive this planetary churn? Exploring these intriguing possibilities is ultimately an exercise in scientific humility and open-mindedness. It serves as a powerful reminder that what we currently know is dwarfed by the immensity of what we still don't understand. The complete story of the emergence and evolution of intelligence on Earth might be far more complex and profoundly mysterious than we can currently imagine. As we diligently search the distant stars for signs of extraterrestrial life, perhaps we should also turn our gaze inward and look deeper into our own planet's largely forgotten past, searching for clues to civilizations that may have risen and fallen before our time. The Silurian hypothesis began as a spark of curiosity, a thought experiment exploring the very nature of evidence and time. It was inspired, perhaps surprisingly, by a Doctor Who episode, a classic piece of science fiction. The episode featured ancient, intelligent reptiles, the Silurians, who predated humanity by millions of years. This concept intrigued Gavin Schmidt of NASA and Adam Frank, an astrophysicist, who together wondered if such a civilization, or any industrial civilization for that matter, had existed millions of years ago, deep in Earth's past. Could we find any trace of it today? What kind of evidence would even remain after such an immense span of time? The hypothesis is playfully named after those fictional Silurians, a nod to its science fiction origins, but the underlying question it poses is a serious one. What would an industrial civilization, regardless of its inhabitants, leave behind in the geological record after eons of weathering and change? Direct evidence, like fossilized cities, perfectly preserved structures or machines, complex artifacts of their existence, would almost certainly be erased by the relentless march of time and the forces of geological erosion. Our oldest cities, the cradles of human civilization, are only a few thousands of years old. After millions of years, even their deepest foundations would crumble and vanish into the earth. Instead, Schmidt and Frank suggest looking for indirect evidence, large-scale, long-lasting changes to the planet's fundamental systems. An industrial civilization, by its very nature, would inevitably leave a chemical fingerprint, a planetary footprint, on a global scale, altering the composition of the atmosphere and oceans. These subtle but pervasive signals might be preserved layer upon layer in rock strata for tens or even hundreds of millions of years, a testament to their presence. The Silurian hypothesis, therefore, isn't about finding a perfectly preserved, fossilized factory. It's about finding the faint, lingering ghost of its pollution, the echoes of its industrial activity. It's about deciphering the story hidden within ancient rocks. The search then is for planetary fingerprints, subtle chemical anomalies, not easily recognizable artifacts. The Silurian hypothesis is a thought experiment, not a claim that ancient civilizations actually existed. Schmidt and Frank make it clear, there's no evidence for lost lizard people or advanced ancient societies. Instead, they ask, if we are the first industrial civilization, how do we know? The hypothesis challenges us to consider how difficult it is to find evidence over vast stretches of time. Absence of evidence is not evidence of absence. By thinking this way, we sharpen our tools for searching for life, on Earth and beyond. If we can't spot a civilization here, how will we find one on another planet? The Silurian hypothesis is a framework for asking better questions about techno-signatures, planetary signals of technology. It's not a conclusion, but a starting point. Earth's surface is not a static entity, it's in constant motion, a dynamic dance of geological forces. This perpetual movement is primarily driven by the powerful engine of plate tectonics, the grand architect of our planet's ever-changing face. Over vast stretches of time, continents drift across the globe, sometimes colliding with each other in slow-motion crashes that sculpt towering mountain ranges, and at other times, breaking apart in dramatic displays of geological separation. Even the ocean floors themselves are subject to this relentless cycle, constantly being created at mid-ocean ridges and destroyed in subduction zones. This constant reshaping means that anything built on the surface, whether natural or artificial, is eventually erased by the inexorable forces of nature, subducted deep into the Earth's mantle, melted down into its constituent elements, or ground to dust by the relentless action of weathering and erosion. Erosion, driven by the tireless work of wind, the ceaseless flow of water, and the grinding power of ice, slowly but surely grinds even the mightiest mountains down into mere pebbles, and buries the past under countless new layers of rock, creating a palimpsest of geological history. Fossilization, the process by which life's remnants are preserved in stone, is a rare and delicate occurrence. Most life, unfortunately, simply decomposes and leaves no trace at all for future generations to discover. Even for species that were once incredibly abundant, like the mighty dinosaurs, the fossil record remains frustratingly incomplete, riddled with tantalizing gaps and missing pieces. Therefore, the odds of finding a perfectly preserved, fossilized artifact from a long-lost civilization are vanishingly small, approaching nearly zero. The geological record, then, is not a pristine library of the past. It's more like a book with missing, smudged, and constantly rewritten pages, a fragmented and imperfect account. In fact, less than 1% of Earth's surface boasts rocks older than 2.5 billion years. The vast majority of ancient landmasses have been recycled back into the Earth, their stories lost to time. In essence, the planet has systematically erased most of its own history, obscuring the secrets of its distant past. That's precisely why we must shift our focus and look for global, subtle chemical evidence, not the easily destroyed physical remains, to unlock the mysteries of Earth's earliest chapters. If we can't find lost cities, what can we find? The Silurian hypothesis says, look for planetary fingerprints, long-lasting changes in Earth's chemistry. Our own civilization is leaving such marks right now. Burning fossil fuels releases carbon with a unique isotopic signature, creating a spike in the rock record. This is accompanied by drops in ocean oxygen, forming black shale layers. Plastics are everywhere, forming a distinct layer of microplastics in sediments, a Plasticine epoch. Nitrogen fertilizers alter the global nitrogen cycle, leaving chemical traces in rocks. Nuclear technology leaves rare radioactive isotopes, like plutonium-244, as unmistakable markers. These fingerprints, carbon, nitrogen, plastics, radioactivity, are subtle but global and long-lasting. They're the kind of evidence a future geologist might find. Our legacy may be written in the chemistry of the rocks, not in monuments. When we look for these fingerprints in the past, we find events that look familiar. The Paleocene-Eocene thermal maximum, or PETM, 56 million years ago, saw global temperatures soar and oceans acidify in a geological instant. The rock layers show a massive spike in carbon isotopes, evidence of rapid carbon release. The cause is debated: volcanic eruptions, methane release, or something else. These are natural explanations, but the event shows what a civilization's geological signature could look like. Other hyperthermal events, like oceanic anoxic events, also show rapid carbon release and global change. Scientists agree these were natural, not caused by ancient industry. Still, these events prove that global chemical fingerprints can be preserved for millions of years. They give us a template for what to look for. The Silurian hypothesis asks, what if just once the cause wasn't natural? The Silurian hypothesis is less about the past and more about our present and future. It reframes our environmental crises, climate change, plastic pollution, mass extinction, as permanent entries in Earth's diary. Our most enduring legacy may be a thin layer of plastic, a chemical anomaly, and a mass extinction in the rocks. This perspective is humbling and alarming. If we want a long-term future, we must build a sustainable civilization, one that leaves little trace. A truly sustainable society would be almost invisible in the geological record. The hypothesis is a cautionary tale. Civilizations that burn through resources may vanish quickly, leaving only chemical tombstones. If others existed, their absence is a silent warning. We have the chance to choose a different path. Will we be the first to understand our impact and endure? The Silurian hypothesis changes how we search for extraterrestrial intelligence. Instead of listening for radio signals, we can look for techno-signatures, planetary fingerprints, on distant worlds. Analyzing exoplanet atmospheres, we might find industrial pollutants or chemical imbalances that only technology could create. A planet with excess carbon dioxide, oxygen, and methane could hint at a biosphere altered by industry. Unusual warmth might suggest a runaway greenhouse effect. This approach helps explain the Fermi paradox. Maybe civilizations are brief, but their planetary impact lasts millions of years. The most durable message a civilization leaves may be in its planet's rocks and air. The search for life becomes planetary archaeology, not just eavesdropping. The Silurian hypothesis expands our toolkit for finding life. We're searching for ghosts, not just neighbors. The Silurian hypothesis brings us back to ourselves and our fleeting moment in time. Our skyscrapers seem permanent, but in geological time, they're as ephemeral as sandcastles. Our real legacy is written in the chemistry of air, water, and rock. This perspective is a call to awareness, a reminder that our actions echo for millions of years. We are the first species to understand our geological impact. This knowledge gives us a unique responsibility. We can choose to write a different ending than the one the hypothesis warns about. Our civilization is just one paragraph in Earth's immense book. The question is, will our story be a brief, brilliant flash, or the beginning of a lasting